Today we're going to analyze the factored form of a polynomial and write the polynomial function from its zeros. We're going to teach you some different ways to write polynomial functions, which could go back to quadratics because they're a polynomial function also. And so, though we've just covered quadratics, some of the skills we're learning today, we could go backwards and apply them to what we've already done. All right? Not all of this is going to be typed out. I didn't have time to fix stuff up. The first one is going to be an example. Something you should already know how to do, but I want to not assume you do. So we're going to do this example. Write the function in standard form. Yesterday we learned standard form had to begin with what? Starts with a D? The highest degree term, right? Nice. And it goes down in order to the least degree term. And so first thing we need to do in this situation, what do you think it is? Yeah, before we're done, you probably will be able to look at this and know what the degree of this is. But if I want to write it in standard form, I need to get rid of all these factors, don't I? So these are all factors. X plus 1 is a factor. X minus 2 is a factor. 3x plus 4 is a factor. How could I not have it in factored form? What would I do? Times them out. Multiply them together. And so you can begin wherever you want. Liz, where do you want to begin? The first two? Okay. Now, when I do this, I have to realize whatever I get has to be multiplied by 3x plus 4. Whatever I get has to be multiplied by 3x plus 4. So I don't want to forget to put parentheses around the answer I get to begin with. Okay? Because all of this answer has to be multiplied by 3x plus 4. And so when I do this, I'm going to FOIL, right? X times x is x squared. X times minus 2 is minus 2x. 1 times x is plus x. And 1 times minus 2 is minus 2. Now some of you will get really good at this and say, do I really have to show all 4 of those? Can't I just combine those as I'm going? And you could have. You could have said the inner 2 give me 1x and the outer 2 give me negative 2x. And what's negative 2x plus 1x? Negative 1x. And so you could have gone straight to this step. Right there. If you're familiar enough with what you're doing and you understand, then you can go straight to that. Okay? So y is going to equal this. Let's not forget to continue. We're looking for a polynomial function. So that's the same as a polynomial equation. So we need to have an equal sign in there at all times. So now who can give me some help? I don't know what I'm doing now. What do I do next to this? Okay, how would I do it? Okay, so tell me what to write. X squared times 3x. What's that give me? Yeah. Let me help you. That's 1x squared, right? So it'd be 3, but x squared times x is x to the third power. X squared times x is x cubed. Okay? Now, what's the next thing I do? Danielle?
Do the x1. The x before the x.
So, tell me what to... You mean minus x?
Yeah.
Okay, times what?
3x and positive 4.
3x. So what is x? What's a negative x times a positive 3x?
A negative 3x.
Okay. What do I do next, Janelle?
Plus 4. Minus 4x.
So, can you tell me what you're doing, or does Danielle have to tell me? Okay, tell me, Danielle, what's she doing?
Multiplying the negative x with positive 4.
Negative x times a positive 4, and you said that's a negative 4x?
Yes.
Okay. And then, Caitlin, what do you think I should do next? There's lots of steps. We're a long ways from being done. Negative 2 times 4. Okay. So what's negative 2 times 4? Negative 8. Natalie. Natalie, what do you think we should do next? Okay, we kind of skipped that at the beginning, didn't we? We also have to say what's x squared times 4. What is that? Plus 4x squared. And there's one more we skipped. Easton? Negative 2 times 3x. We didn't do that one yet, did we? Which is negative what? Negative 6x. Now, sometimes when I scatter it around the room and break up responsibility, we get something that's kind of a jumbled mess. I personally, I would think about it the other way, and I would say, let's do 3x times each one of these. And then I would say, what's 4 times each one of these? It doesn't make my answer more right than yours. It just means I might have less chance of forgetting something. Okay? So if we simplify this, are there any other x cubed terms? And I should have asked this first. Is that the highest degree?
Yes.
Yeah. So the next degree would be x squared, right? So we have an x squared here and an x squared there. How many do we have?
Just one.
Just one, because this is minus 3 and plus 4 is plus 1 x squared, or just plus x squared. Then I have a minus 4x and a minus 6x. Negative 10x. Good job, Mason. And then I only have one constant, don't I? So minus 8. What's the leading coefficient on this one? What's the leading coefficient? 3. Just the number in front of the first term. When it's in standard form. Sorry, I didn't hear you. Maybe it's because you had that fruit roll-up half glued up between your teeth. What's the constant? We already said it, but what is it? Negative 8. So if they give you a polynomial function in the form of factored, or in other words, in factored form, you need to write it in standard form. You simply have to multiply it out. Okay, it's going to be kind of ugly at times, depending on how big the polynomial is, but you have to multiply everything. The key here is not to forget this. Okay? You have to multiply everything you get from the answer to the first two by the rest of it. And if I had another one up here, then I'd have to take all of this answer and multiply it by that. Okay? I'd have to take all of it. You can't just break it up. Please don't talk when I'm talking to you. All right? Any questions on this one? Okay, moving on then. Constant. So this one says y equals 3x cubed plus 2x squared minus 3x plus 1. Graph on your calculator and find the relative minimum and relative maximum. So once we graph that, if you don't have your calculator, you need to get it. You need to get in the habit of grabbing it when you come in the room with this out. Once we graph this on our calculator, I'll show you where you'll find the relative minimum, relative maximum. I'll show you how to do that. Okay? So I'm going to type my equation here. Anybody tell me what it was? 3x cubed plus, oh, thank you. Oops, I didn't mean to do that. 3 plus 2x squared minus 3x plus 1. Did I have it copied correctly? Okay. Thank you for catching that. When you're typing it in, make sure you don't do the same thing I did. Don't let it stay in the exponent. Okay? So when I press enter, it's going to graph that for me.
Alright, so quick question. Do all of you know how to plug this into your calculators? Okay, I know some of y'all are like me, so do you guys want Mr. Mitchell to go through how to plug that into the calculator slowly? You can blame it on me if you want, I'm good with that.
My calculator's like waking up.
It's waking up.
Okay.
Waking up. It's doing the laggy.
Did you start with the new document?
I went to grab
You start with the new document.
There was nothing on it.
I did that also, and then
I think there's probably something else going on inside.
Okay.
I hope that's the reason.
Yeah.
Otherwise, we'll have to send it back and figure it out. Okay, now, we have not talked about relative minimums, relative maximums. Are you listening? A relative minimum means relative to all the points around it, it's the lowest, it's the smallest y value. The relative maximum means relative to all the points around it, it's the biggest value. Okay? So minimum would be the smallest. Well, sorry. Let me pause. So those would be my definitions. I'm sure the book has some fancy technical terms they use. But I just want you to understand relative minimums, relative maximums don't mean that they are the biggest point on the graph or the smallest point on the graph. Unlike in a parabola where you have that, we don't have that in this setting. You'll notice this graph, I can't touch the screen and it'll mess things up, but this graph continues to go up and up and up, right? And down here it continues to go down, down, down. But if I look at these little bumps we have in the middle of the graph, this point right here that looks like it's like a -1, +3 right in that area there, I can't touch it. But if I could, it would be right in that area right there. That would be a maximum compared to all the points around it, wouldn't it? And this point over here, like 1/2, 1/2, that would be a minimum compared to all the points around it, wouldn't it? That little bump, that's the smallest point possible in that area right there of the graph, in that region of the graph. I should say area. In that region of the graph. Okay? So, those are where the minimums, the relative maximums are going to occur. So I'm going to select menu. And what do you think I want to do from the menu? I want to analyze. I want to find find something out about the graph. So I'm going to analyze. Okay? I want to find a minimum. And so I have to move this now. I'm looking for, I selected minimum, so I have to do this. And it says lower bound, so I need to be on the left side of my minimum. Okay? Left side of my minimum. So once I get to the left side of my minimum, I hit enter. And now it's going to say upper bound. So now I need to move to the right. And when I'm to the right of that minimum, I hit enter again. When I do that, I get that point right there. So what is my relative minimum? Some of you struggled with this on the test. When we were looking for minimums and maximums, you're confused on what it meant. Looking at that ordered pair, what is my relative minimum? What, say louder? Let's go back to this for a second. What does it say the relative minimum is? The smallest y value compared to all the points around it. So if I go back to this, what is my relative minimum? 0.312. Okay? 0.312. Now we're going to find the relative maximum the same way. So we go menu. Go to menu. Go to analyze. Now I want the maximum. Then I have to go left to get to the left of the maximum value. So that's good, right? I'm left of it. It wants the lower bound, so I have to be left of it. Press enter. I don't know what just happened. Now I'm going to do it again. I must have pressed something wrong. Oh. Make up your mind, computer. What are you doing here? Well, that should work. I'm certainly left. I'm way more left than I needed to be, but I'm certainly left. There we go. So what's my relative maximum, Devin? 3.15. 3.15, that's correct. So my minimum was 0.312. My maximum is 3.15. Okay? So that's how we find the relative minimum, relative maximum on our graphing calculator. And this is what our relative minimums and maximums mean. Okay? Moving on. Factor theorem. The factor theorem is a very simple concept that sometimes is written in a complicated way and confusing to people. So let me read it the way it's written, and then I'll try to explain it better if this isn't good for you. X minus a is a factor of a polynomial if and only if a is a zero of the polynomial. So if a is a zero, then I can write it as a factor as x minus a. And we're back to that concept when it's inside the parentheses, the sign is opposite. That's what's happening here. It doesn't say x plus a, it says x minus a, so it's throwing a negative in there. So if a is a positive 3, my factor would be x minus 3. Okay? I'll pause while you get caught up and then we'll do this example. So in this example, they want us to write a polynomial function. Okay? So you can think of it, it doesn't mean exactly the same thing, but you can think of it as a polynomial equation, which means we have an equal sign in it. And typically when we talk about functions, we think of f of x. On our calculator, it doesn't say y equals when we type in the equation, right? It says f of x equals. Well, because we want a polynomial function, a lot of times they say p of x. It's not wrong if you wrote f of x. It's not wrong if you wrote y equals. Quite often, because it's a polynomial function we're looking for, we write it as p of x. And now we're going to fill in what we know. Well, these are the zeros. And this theorem says if a is a 0, then x minus a is a factor. So if a is a 0, then x minus a is a factor. Well, if my 0 is negative 5, what's my factor? Louder, please. X minus a negative 5, which is x plus 5. That's correct. If 2 is a 0, what is my factor? Someone other than x minus 2. And if 3 is a 0, then Caleb, what do you think the factor is? Louder, please.
Should be 3.
No, 3 is my 0. How do I write that as a factor?
X minus 2.
There you go. X minus 3, that's correct. Okay? So they told us to write a polynomial function. I have it. That's it. I don't have to do anything else. That's my polynomial function. Now, if they said write my polynomial function in standard form, then I'd have to go back to that first example. After I wrote it this way, I'd have to multiply everything out and put it in standard form. This doesn't say that, does it? It just says write a polynomial function. And I'm going to tell you, if my answer key has it in standard form and you have it this way, and then it tell you you had to change it, this is easy for me to look at and know that it's right or wrong. Really easy. So it's not a big deal to me if you stop right there when you don't have to write it in standard form. In fact, I'm telling you to do that because if you write it in standard form and make a mistake, then I got to take something off because it's not right. I wouldn't take much off if you showed me this step and had it right. But unfortunately, you'd still lose 1 point if you changed it and had it wrong. Okay? So if they don't tell you in standard form, just stop right here. Do you have any questions with what this factor theorem allows us to do? You notice from geometry it says if and only if. It means it's reversible. When I used it here, I said if a is a 0, then x minus a is a factor. I switched it around, didn't I? And if they give me factors, then I can look at the factors to find the zeros. If x minus a is a factor, then a is the 0. Okay? All right. Any questions on that before I move on? Here's my zeros. You try it. I've got my polynomial function all set up for you. Write that for me. Finish it. Let me pause while you guys do that. Audrey, what'd you get for the first one? X plus 3. Good. Aslan, what'd you get for the second one? X minus 2. And for the third one, Noah? X minus 2. Were any of you confused when you got to here and noticed it's the same as this? Good. It's the same 0. Doesn't mean that it's doesn't need to be there. It still needs to be there. Okay? It still needs to be there. Even if a 0 occurs more than once, if you're putting it in factored form, you need to write it there. Now, you could, if you wanted to, I would not, again, just because if they didn't ask you to do it, I wouldn't. But it could be rewritten this way and still be in factored form. Since I have x minus 2 twice, I could write it as x minus 2 squared. Okay? But you don't have to. And I don't even recommend it unless I tell you you have to put it in standard form. And even then I wouldn't recommend it because most of you don't know how to multiply that out written that way. You put it this way. Written that way, most of you make a mistake. And I'm going to show you that mistake a little later today. Hopefully I'll be wrong. Hopefully you prove me wrong. That's why I tell you those things. Okay? But my experience is most Algebra 2 kids make mistakes in that. Now, if you're going to multiply it out, I would leave it in this form and multiply out from there. Be less mistakes that way. Okay? Moving on. What's the zeros of this one? I heard a -1. Someone else?
2.
2. 2 again. And a +5. I agree with that. You see that x minus 2 is squared? So that means that 0 occurs twice. So I should write them down that way. Can I move down? I asked that wrong. Anybody not ready to move down? That's what I meant to ask. 2 is a multiple 0. Occurs more than once. 2 has a multiplicity of 2 because it occurred twice. So the terms we're trying to learn here is multiple zeros and multiplicity. Multiple zeros are any zeros that occur more than once. Multiplicity is how many times do they occur. Okay? I might have an example on the next page, but to be honest, I don't remember seeing it. So I'm going to create a different one here. Give x equals x minus 3 squared, x plus 4, 4, x minus 1. So I have some multiple zeros here, don't I? Mason, can you name one multiple 0 for me? 3. And what is its multiplicity? 2. Who said 2? Easton. 2. So we would say 3 is a multiple 0 with multiplicity of 2 because it occurs twice. Katie, can you give me another multiple 0 up there? Almost. No. What's wrong with the 4? -4. Remember it's the opposite sign? And so it's a -4. And what is its multiplicity? Can someone tell her what multiplicity means? How many? 4 times, that's correct. So we have 3 with multiplicity of 2 because it occurred twice, and we have -4 with multiplicity, that's a C, of 4 because it occurred 4 times. Okay? Did I lose anybody on multiple zeros or multiplicity? You could, but we normally don't assign a multiplicity unless it's multiple zeros. If it only occurs once, it's not multiple zeros. Yeah.
So, Mr. Mitchell, would an easy way to find the multiplicity be to just look
As long as it's written like this, absolutely. That's an easy way to find it by looking at the exponent. Sometimes they might have them all listed out, like we did back here. We didn't write it as x squared. We did later to show you, but it didn't have to be. X minus 2 squared, I mean. So, depends on how they give it to you. Okay? Alright. Just looking at the factor, looking at one factor, and so we're looking at this factor, what does x minus 3 mean? I'm going to give you a minute. This is tough for me, but I want you to discuss in your groups all the things that x minus 3 means here. Okay? We don't have time to just chat for the rest of class, so we'll come back. X minus 3 is a factor, right? Yep. So but what I want you to do is look at what's really happening in that function and tell me what that 1 means. Okay, and so it means it's a factor of the polynomial. Someone else told me something else. What'd you tell me? What is? What'd you tell me already, Alex? I don't know what you said. I couldn't hear you. A 0 is. Okay. What if you switch it around and said 3 is a.
3 is a 0. It's a positive. 3 is a 0.
3 is a 0. That's what she was telling me before. And now she's turning around in a backwards way and it doesn't sound good. Okay. So you're telling me that 3 is a, 3 is a solution to the equation. 3 is a 0 to the function.
So basically, I just should have said positive. I just should have said 3.
Okay. And 3 is an x-intercept to the function. 3 is an x-intercept. So if I graph this, I'm not going to, but if I graph this point where it crosses the x-axis, that's the x-intercept. That's where the 0 occurs. Why does the 0 occur there? Anybody know? On the x-axis. Why does the 0 occur? Why do we call that 0 on the x-axis?
That's when y equals 0.
Because that's when y is equal to 0. That's exactly right. That's when y is equal to 0. And remember the function here says p of x, and so if we put a 0 in here, the y value would equal 0. And what would make y 0? Well, 3 would make y 0. What else would make y 0? Negative 1 and negative 2. So my zeros in this one would be negative 2, negative 1, and 3. Those would be the x values. Those would be the solutions to make this 0. Those would be the x-intercepts. Okay? Those would be the x-intercepts. All those things are true when you're looking at one factor. You need to have all those written down. So that's where I want you to have that understanding. I want you to get to the point where you recognize all 4 of these things are true because you know that one factor. Or you know that one 0. Or you know that one x-intercept. Okay? I'll pause since some of you weren't. Here's that problem I was talking about earlier. When hopefully I incorrectly accused you of most of you getting this wrong. Most people unfortunately look at this quantity squared and tell me this. Because you square x, you square 6, and you tell me it's x squared minus 36. That's wrong. If we wrote it as 2 binomials, x minus 6 times x minus 6, and FOILed it, we would end up with 3 terms. The last term always has to be positive because you're squaring. What's negative 6 times negative 6? Say it again for you. I know some of you are writing. What's negative 6 times negative 6? Positive 36, right? Negative times a negative is a positive. Okay? So when I square that negative 36, I have to get a positive 36. And when I square x, I have to get a positive x squared. But that middle term is going to have the same sign as this one. And how I get that middle term, the shortcut method we used to call it, I multiply x times 6, what's that? Times 2. No, I didn't say square it. I said 6x times 2. So I get 12x. Now let me show you why, even though some of you may already know. If I write it this way, x times x is x squared. Negative 6 times negative 6 is plus 36. And these two are my middle two, right? My inner two in FOIL. And these two are my outer two in FOIL. And for the inner two, I get negative 6x. And for the outer two, I get negative 6x. So how many negative 6x's do I get? 2 of them. So that's why I say x times 6, or the first times the second, times 2, because there's always going to be 2 of them. We don't square it anymore, we just times 2. So the shortcut, square the first, square the last, find the product, times it by 2, that's the middle term. Okay? And so I get minus 12x. You say something, man? No. Any questions on that? Hopefully, you'll prove me wrong, and none of you will ever make that mistake. Unfortunately, history is not on your side. But you could be the first. You can change history. Again, this is not expected to be done tomorrow. This is what I'll give you tomorrow to work on. Just give it to you now.